Hello, we're at this place in Copenhagen, RML Space Lab, where we're trying to launch a human being into space. To do so, we built this launch pad. And within the building behind me, we are constructing some of the most powerful amateur rockets that has ever been built. One of the things that we need to get accustomed to is to actually take a human being, one of our friends, and strap him into a rocket, connect it to a rocket engine, and light that rocket engine and launch him. And in order to train that, our company came up with this idea of a human centrifuge that could expose a future rocket pilot to G-loads, but also expose the ground personnel and the flight director and so on to the whole concept of strapping a human being to a rocket engine. So we built the seat and the rocket engine. Behind me we have the very first manned rocket vehicle that we've ever built in the Space Lab. The seat here is exactly the same as we're going to use in our space capsule that we're going to launch atop of a very powerful booster out of Earth's atmosphere and into space, and then recover by parachute. And strapped into the seat right now we have this young gallant rocket pilot who is going to be propelled to very high G-loads with this system. The way that it works is that it's attached to a rotor on these two hinges. And as this rocket engine in the back fires, controlled by the rocket pilot, this whole vehicle moves in a circle around a concrete counterweight. The 4 pieces of concrete behind him is 10 tons of concrete that basically holds this whole structure in a trajectory which is a circle around the middle of it. And by moving at high speed in a very tight circle, we produce G-loads, we produce centrifugal force that will force the young gallant rocket pilot into the seat in the same way as he would experience in a plane making a tight turn. But it turns out that with the position of the seat in our rocket, it's the same G-load direction, G-set as it's called by professionals, that we're going to be exposed to when we fly a human into space in our rocket. On the back end here, we've got the business end of this rocket seat. First off, we've got the rocket engine. This is a very simple hybrid rocket motor. It works by having 2 tanks of liquid oxidizer feeding oxidizer through a valve into the engine. Within this pipe there is a block of rubber fuel, so we basically burn rubber fuel in a liquid oxidizer. This rocket engine produces a thrust in the order of the same force as would act on a mass of 170 kilos. We can call that 170 kilos of rocket force. So it's got so much power that if we had this on some kind of a sled, it would be able to go up an inclination of some 70 degrees. It's very powerful for the size of this structure. We've got fuel enough here for something like a 15-second burn. Within 15 seconds, this engine would consume all the propellant within itself and within these tanks. But at that amount of time, we would reach G-loads that were far beyond what the rocket pilot could remain conscious in. So we are going to burn it for a shorter period of time. After about 4 seconds of operation, we should be reaching 4 Gs. After about 6 seconds of operations, we'll be reaching 8 Gs. So somewhere around there, we should run out of fuel. So we short fuel this vehicle. We do not load up the oxidizer tanks to their capacity. We simply load it in such a way that we know that this thing, even if the pilot chose to operate the engine till its burnout, would not give him accelerations he could not survive or sustain. What happens when you accelerate at very high G-loads is that ultimately, in this kind of seat, with this kind of person, with this kind of situation, you would pass out and go into what's called G-lock at a G-load in the order of 6 to 10 Gs. Somewhere in that range, you'd lose conscience. And when you do that, you would let go of the firing knob that makes the engine go, and you would release that. The engine would shut down, and you would get back to normal 1 G load and regain conscious. But we should never go there. We are planning for a 5-6 G burn for the first operation of this one, somewhere between 4 and 6 Gs, which is well within what you can be exposed to without losing conscience anywhere near. The actual purpose of the experiment is to test the psychological effect of strapping a human being to a rocket engine. During a rocket flight to space, we will expose our astronauts to less than 5 Gs. This seat can expose our astronaut candidate up to 8 or 10 Gs, so we have some level of overkill. But this, of course, because we want to find out where the limits are with this seating position. More important, however, is in fact the training of the ground personnel to fuel the rocket, to set everything up, make it ready, and fire it with one of our friends in it is a psychological barrier that one should not underestimate. And we are making this experiment with the human-powered rocket centrifuge to adapt ourselves to the incredible thing that it is to take one of our friends, strap him to a rocket, and launch him in direction of space.